This is the final project for embedded systems. Our team is Eric Gonzalez, Daniel Lara, and Dwayne Barrientos. So let's explain a little bit about our LabVIEW code. This is the Project Explorer. Our main goal is to generate different frequency and amplitude signals depending on the user and depending on one figure that is here. So it's detecting by vision the figure. So depending on what figure the user interacts with, it produces a different frequency and amplitude signal. We are using the MyRio to output audio using the audio out jack. So as you can see, if I interact with any of the figures, it produces different frequencies. The frequencies are configurable, and the main goal is to produce a little game for kids. So if we see the code in LabVIEW, we have three parts of the project. One is the VI for the host, the My Computer host. This is a post-production VI. Then we have VI in the chassis of the MyRio. This is using the FPGA. We can see it now. We're using this because to produce the audio using the MyRio, we have to, or it's the best option to use the FPGA because it's fast and the reliability of the FPGA. We're only using the sine wave generator. We are sending the frequency and the amplitude of the signal, and it only merge that signal and send it to the audio out, audio left and audio right of the FPGA. So we are sending this information via another VI in the RT Target. This VI, what it does is, you can see the front panel here, it allows the user to select a frequency and an amplitude for each of the figures, of the 6 figures. It also shows the vision of the figures and the detection of the figures. And in the block diagram, well, it shows the selection. It has a boolean in order to show the user what figure is interacting with. And we are sending this information to the FPGA using these blocks. First of all, an open FPGA VI reference. We are also using an invoke method. This is in order to run the FPGA program. And then we are using a read-write control, only to, depending on what the user selects, it sends the amplitude and the frequency of the signal to FPGA. Finally, we have a closed FPGA reference. And we also have the vision acquisition and the vision assistant. For the vision, we use the shape matching. So what we are doing is comparing the matches. So in this case, if the figure is not present, so if the number of matches is 0, it demonstrates that the user is selecting that figure. So it goes to a select and it chooses that option of amplitude and frequency that it's part of that figure. And finally, we have an extra feature in the host, and in this post-production VI, it allows the user to the recorded sounds that he made. He can upload it to the VI. In this case, it's a song. He can use a filter, Butterworth, Bessel, Chebyshev, elliptic, or it can invert the signal. Can choose the type of filter and the cutoff frequency, and choose where it's going to be saved. So in this case, we're going to choose a directory. It's desktop, and we're going to run the VI. It runs, it shows the the output, the original image and the inverted, the original signal and the inverted signal, and finally we have audio file, and it shows this, in this case the song but inverted. So finally we are going to show the final implementation of the project. I'm just going to demonstrate the detection.
¿Cuántos cables van a necesitar? Ajá.